point and the image point. Okay, so that's kind of the key idea to know there. All right. So, how do we find the if I map this onto this, how do I find the center of rotation? You can see it turned to get there, but where was the center of rotation? I'm going to go back to, and I'm going to just go through this step by step, like what I said before. Focusing on Q and Q prime, I know that if I draw a line from Q to Q prime, and let me just, again, I'm going to change its color. I'll go ahead and keep it thick. I know that the midpoint of that can work, so I'm going to construct its midpoint. Okay, the middle of this line is a possible way, and just focusing on Q. I want to rotate Q onto Q prime. I'm not going to worry about anything else. Okay, I know that this midpoint is a possible center of rotation for mapping Q onto Q prime, but I also know that anywhere on this perpendicular bisector is a possible point as well, right? Any point along this line could be used to map Q onto Q prime, okay? Now let me choose another pair of points. How about P and P prime? I'm going to draw a line between them. I better give them a different color. How about blue? Okay, I know that the midpoint could be a center of rotation mapping P onto P prime. Okay. But I also know that any point on the perpendicular bisector can also work. So I'm going to construct that perpendicular bisector. Okay. And I know that any point along here, along this blue line, would map P onto P prime with a rotation. Well, check this out, right? I've looked at 2 points. It turns out that there's a shared point down here, right? This particular point is found on both lines. It means that this particular point can rotate Q onto Q prime. It also means that this particular point can rotate P onto P prime. So this is actually the center of rotation. I found it. It's right here. All right, so this is the center. Okay, and it's, what is that? That's the point 1, -1, it turns out to be in this case. Right there. And I mean, I could go R primed and I'd find the same. It should also go through here as well. Once I find 2 points, I found them all, right? So I know the center of rotation that's going to work here. And then the next thing is, well, okay, so what was the angle of rotation? And again, what I can do is I can say, all right, if I draw a line from Q to the center, and let's make this a different color, of course. How about purple? And then from the center back out to Q, I can see that, oh, look, Q swept through this angle, right? Q started here, ended up over here. Clearly, that's a 90-degree angle, and it's a positive 90-degree angle, right? Or you could also describe it as being an anti-clockwise 90-degree angle. So to answer the question that was posed here, completely describe this transformation, my answer would be as follows. PQR is mapped onto P prime, Q prime, R prime, via a 90-degree, I'll call it anti-clockwise just because I want to impress my examiner, anti-clockwise rotation with the point 1, -1 as the center of rotation. All right, again, easy for me to fly through this. It takes a long time for a kid to understand this, so be sure to spend a lot of time on this. Okay, let's move on to enlargements and the qualitative feel for an enlargement. First off, here's an observation I need to be explicit about. You should have noticed that the translations, reflections, and rotations that we've looked at so far have always produced images that are congruent to their objects. Okay, so it's like we take a shape and we translate it, or we flip it, reflect it, or we rotate it. Regardless, the image is always congruent to the original object. An enlargement involves rescaling the size of the image, and hence will produce an image that is similar to the object. Now, the word that we use in America is dilation. We don't use enlargement. And I think enlargement is actually an unfortunate term. We'll see why here in a minute. But in Jamaica, they use enlargement, so that's the vocabulary we need to use when we're down there. I'm going to provide a few examples. An enlargement always has a center of enlargement and a scale factor. So here's an example. Okay. Clearly, I've blown up FGH, right? I've made a bigger triangle here. And specifically, FGH is enlarged by a scale factor of 3 with the origin as the center of enlargement. This is how I know that. Notice that the distance from, O is the center. Notice that the distance from O to H is a distance of 1, 2, 3. Okay? The distance from O to H prime is 9. It's 3 times as far away. So that's where the scale factor, we scaled it up by 3. The distance from O to H prime is 3 times as much as the distance from O to H. This is going to be true of the other points as well. So for instance, from O to F, it's like 2 diagonals, 1, 2. We would expect O to F prime to be 6 diagonals, 1, 2, 3, 4, 5, 6. Sure enough, the distance from O to F prime is 6. The distance from O to F is 2. The distance from O to F prime is 3 times as far as the distance from O to F. The distance from O to G is 1, 2, 3 diagonals, so O to G prime should be 9 diagonals. 1, 2, 3, 4, 5, 6, 7, 8, 9. Sure enough, it is. Okay, so that's one example. Here's another example. The origin doesn't necessarily have to be the center of enlargement. This time I'm going to use the point H as the center of enlargement, and I'm going to use a scale factor of 2. So, H is the center. The distance from H to H is 0. So H prime also is located here. In fact, I should have even shown that. H prime is here. Since the distance from the center H to the point H is 0, the distance from the center H to the image H prime is also 0, 2 times 0. The distance from the center H to G is 1, 2, 3. So the distance from H to G prime should be twice that. 1, 2, 3, 4, 5, 6, sure enough. To get from H to F, I go left 1 and up 2. So I've got to double those distances to get from H to F prime. Left 2 and up 4, sure enough, it works. Get this out of here. One last example. And this is why I don't like the word enlargement. An enlargement can also make an object smaller, right? If you use a fraction as your scale factor, the object will get smaller. It won't get bigger. So that's why I don't like the word enlarge. But anyway, here O is the center of enlargement, and the scale factor is a half. So notice that the distance from O to H is 3, and the distance from O to H prime is 1.5. So it's half the distance. Distance from O to F is 2 diagonals. The distance from O to F prime is 1 diagonal, half the distance. The distance from O to G is 3 diagonals. The distance from O to G prime is 1.5 diagonals. Okay, so that's how enlargement works. Now, here's an example of a problem a student might get. Enlarge triangle PQR by a scale factor of 2 using the origin as the center, and then state the coordinates of the image after you do that. So here I've got PQR. Okay, well, I know that the distance from O to R is 2, so that tells me that I need to double that to get from O to R prime. Okay, O to R is 2. My scale factor is 2, so I want to double that, so I'm going to go 1, 2, 3, 4. That guy right there has got to be my R prime. Okay, I doubled the image. I doubled the distance, excuse me. To get from O to P, I have to go 1, 2, 3, 4 to the left and 1 down. 4 to the left and 1 down. So I'm going to double those distances to get my P prime. So rather than 4 to the left and 1 down, I'm going to go 8 to the left, which is over here, and 2 down. And right there is my P prime. Okay, and then finally, O to Q, I need to go 1, 2, 3 to the left and 2 down. Let me double those distances. Instead of 3 to the left and 2 down, I'll go 6 to the left and 4 down. There's my Q prime. Alrighty, let me connect those dots. There's my triangle. You should notice that it is similar, mathematically similar to the first triangle, same angles and all that other stuff. It's just sort of, the lengths are twice as big. Okay, so that's how that works. And then the final type of problem we might see is I might show you an enlargement and ask you, well, describe it completely. What is the center of enlargement and what is the scale factor? Okay, now remember, as we saw before, that center of enlargement doesn't necessarily have to be off the objects, but many times it is. Like notice over here, the center is kind of located over here off of the two triangles. I did show an example earlier where it's possible that maybe the center point is actually on, and then it'll kind of look like this. But regardless, I'm going to come over here Now, one property about that, and let's start by finding the center. I know that the center has to be located on the same line that connects P prime and P. I'm going to draw a little ray here, right? I know that the center has to be somewhere along this line, or this ray that I've drawn, okay, that passes through P and P prime. Likewise, it has to be located somewhere along the line that connects R and R prime. And it has to be somewhere along the line that connects Q and Q prime. Well, a shared point emerges. Here's your center right here. Okay, that has to be your center. Okay, and now let's look at distances so that we can figure out the scale factor. The distance from the center to P is 2, and the distance from the center to P prime is 1, 2, 3, 4, 5. So 2 multiplied by what equals 5, and the answer is 2.5. That's your scale factor. Let's test that again, make sure it still works. Let me try R. To get to R, I can move along 2 diagonals. 1, 2 diagonals. To get to R prime, I move along 1, 2, 3, 4, 5 diagonals. Yep, I multiply this distance, 2, by 2.5 to get my distance from the center over to R prime, and that should work for Q as well. So a complete description here would be PQR is enlarged by a scale factor of 2.5 with the point, and what is that point? That's the point, here it is over here, 2, 1, 2, 1 as the center of enlargement. Alrighty, one more video to go, and we will be looking at matrices and transformations in the third and final video.